Okay, so let me see. Next, we have Mr. Bryan Sinclair, and Bryan is with us. Let me do an introduction here first, though. So pulsed inertial engine technology is the PI technology that Bryan is working on. It's an open source vehicle propulsion project, builds on an incredible framework developed originally by Branson Roy Thornton nearly 50 years ago in the 70s and 80s. So Bryan is going to describe his progress on his new working prototype demos. He has a prototype called Pi-X, and he is doing some pretty major revisions to it that he is going to try and demonstrate for us today. So let me see. Bryan, are you there?
I am here. I am here.
Perfect. Let me spotlight you for the audience. Awesome.
Well, thank you very much, Tim. Yes, right now we're doing some pretty major revisions to the insides of it. I'm still not completely divulging what's going on inside the new unit. It does work on all the same principles as the original Pi 1, Pi 2, and Pi 4. Pi 3 is actually reserved for someone who is working in collaboration with us. So the 3 series actually is someone else's. The Pi-X, honestly, I called it the X because I didn't know what number to call the doggone thing. So really and truly, I've renamed it sort of as the Trammel Engine. It's only an engine because it is producing power. It does run on electricity, so there is an electric motor making it run, and it's producing. It has produced quite a bit of thrust, and I've also broken a lot of internal components in it, and that's why we're doing some major revisions. I do have a little presentation that I can put up on PowerPoint. Let me share my screen. And this is a little something I'm called closed loop propulsion. And let's see. And we will go with well, we can leave it pretty much the way it is, I guess. So anyway, I want to introduce closed loop propulsion. And Mike Melia, you did a terrific job. I really like your system. I like the way it looks, and I like the way it seems to be working. It's a really, really good job. Some of this will build on that. Some of this will build on the UAP phenomenon, and some of this will build on some of the work I've already been doing. So right now, I've got several parts to this little presentation. It's not going to be very long, so don't get worried about the part 1 thing. So anyway, let's see. It is a 3-part presentation, and I will relate this part 1 to kind of to the UFO UIP phenomena, along with inertial propulsion and what we're now calling closed loop propulsion in many cases, and what it always used to be just sci-fi. Now it's more becoming a reality. So it's really coming into its own at this point. Just a few years ago, no real scientist would have ever been taken seriously. In fact, just the mention of a reactionless drive or inertial propulsion or closed loop propulsion would literally ruin someone's career. I mean, they would be called all kinds of terrible names. It was a conspiracy. They would lose their funding. People have lost their jobs, and they have literally been silenced over this type of thing. Wikipedia calls it a reactionless drive as a hypothetical device. Well, we're knowing now that it is no longer hypothetical. So what has changed? A partial answer is APEC. APEC is doing a terrific job of really bringing this into the mainstream. And along with the mainstream disclosure and revised terminology, where we call UFPs are now being called UAPs, and inertial propulsion, now being called closed loop propulsion. The concept, I guess my next question is the concept of closed loop propulsion being embraced or just tolerated? Are they only just tolerating us just because they haven't been able to figure out how to make us go away yet? Let's see. It's still a steep uphill trek. Many years of absolute denial from the scientific community, just like we've had with the UAPs, mandated patent denials. I know we've heard from others who have said that they couldn't get a patent on any part of their device until they called it a teaching device or something else. Been a lot of smear campaigns used to discredit people who have built anything that mainstream science, well, just plain doesn't like. Eyewitness denial. I know very well that there have been people like Roy Branson Thornton who have taken those devices to large institutions. He's demonstrated them. They said, that's really neat. And then they turn around and said, no, it doesn't work. It's absolutely astounding how a successful demo unit is still publicly denied. There have been a lot of claims of being strong-armed into silence. Information has been twisted, and they use scientific proof to discredit what we do. Professional scientists refuse to engage discourse with us amateurs, and I do put myself in the amateur league. I don't have a PhD, and I never claimed to have a PhD. Statements like inventors aren't real scientists have been removing our credibility for well over 50 years. And even some alternative tech communities, not APEC, obviously, have denied the plausibility, making closed loop propulsion into just a plain joke. So are we really expected to believe that this is being embraced? I don't know. I certainly hope so. And I'm moving forward as if it is. So information or disinformation. These are the information wars. We hear a lot about it on the news. New info is coming at us hard and fast, and we sometimes don't quite know what to do and what to take and what to believe. Disinformation is still thrown into the arena, and it just confuses everything, making real information very obscured. So the old saying, will we be dazzled with brilliance or baffled with bull? Well, I guess we'll find out. So I do have the utmost respect for all of the amazingly brilliant people who are innovating our world using theoretical innovation along with real world mechanical innovation. We all, mostly all of us, love to see the theories, the math, and we all know the importance of those theoretical physics and mathematics. Proof is what's been demanded. They still demand proof. And it's absolutely amazing. You can take a machine like Mike Melia's and put it in front of a group of scientists, and they would say, I don't see any proof. It should be more important to have working demonstrations. To me, functional, examinable, replicable prototypes are their very own proof. There's no other proof should be necessary. Let's see, I think I have gone too far. There we go. Extraordinary claims require extraordinary proof. That's been an old motto going along for a lot of years. I'm not here to prove anything. I'm only here to demonstrate what I've been able to accomplish. And I just want to define the difference between proof and demonstration, because to prove means that something is denoted that it has the assumption that something actually needs to be proven because it has been considered impossible. To demonstrate, something is simply allowing a person or persons to see for themselves what is being accomplished. Done properly, I believe it provides its own proof. Do mainstream engineers with working demos and prototypes have to prove that they're real? No. When we're open and forthcoming, I don't see why we have to either. So a few ground rules for my own shop, my own lab, my own prototype division. Proof happens in my own shop settings. I have nothing to prove otherwise. All prototypes are replicated before demonstrating. I don't demonstrate anything that I can't repeat. If it's not repeatable, it's not worth demonstrating. All demonstrations are explained, and open source is not always the best policy, but it certainly is the safest one in the way I see things. All demonstrated prototypes are replicable. All prototypes have details to replicate and improve. Some of those at this time are still requiring a legal NDA. We never offer any wild or untested theories. We never use personal education level for expert status. And we never state anything as being a fact unless we can back it up with absolute 100%. So to everybody working on things like this, never forget personal, physical, and intellectual protection. We talked just a few minutes ago, Mike, you mentioned about the intellectual protection of having a patent. Unfortunately, sometimes patents do really nothing to protect anything. They only give us the legal right to sue for damages once somebody has stolen it. Trade secrets, to me, that is exactly what they need to stay. Trade secrets need to remain just that, secrets. So Mike, Melia, you're doing a great job. Information, it needs to be shared with care. And we do that on this, in this forum, in this format. And we share what we know and what we can do, and we try to improve on it as a group. Just and lastly, locks. Just like patents and passwords, they only keep honest people honest. So, you know, until they become a little bit more foolproof, I guess that's the way they're going to stay. So, pieces of the puzzle, part 2. Part 2 is closed loop propulsion, or CLP. I'm not here to give a physics lesson. Nobody here needs that. I'm not covering the experimental math or much actual math at all. And this is based purely on actual direct experimental results, and anything theoretical will be identified very clearly as being an untested theory. So, ingredients that we need to create a closed loop propulsion machine. Some of us know these ingredients quite well. AM, or angular momentum, that is general, that it absolutely has to be within the machine. Compound angular momentum, which can be described as orbital. Angular velocity, which is not linear, and linear inertia, which is thrust and anti-reversion, which was also spoken of in the last presentation, where gravity tends to pull something back. That's the reversion. If there's any kind of a reverse pulse, it works with gravity to just counteract any forward movement we have. Rotational inertia is where we store the power in the unit, and centripetal and centrifugal force, they cannot work alone to make any of these units work. Now, T is something that we don't talk an awful lot about, but it is time. Time, and it's relative to the internal components of the unit. And that is what we have to build our angular momentum along with time in order to have a successful working unit. Some common confusion or commonly confused items in the prototypes: centrifugal force versus angular momentum. Centrifugal force is just that outward force. A lot of people even deny it, even today, still deny that it exists. Angular momentum, however, definitely exists. It's proven, it's seen, it's workable, and we can do the math for it, but we're not going to do that today. Angular momentum versus centripetal force. Same thing. Centripetal force, just the force trying to push away from the center. We need to use the angular momentum of that centripetal force. Linear momentum versus angular momentum. A lot of people still figure that you can't take an angular momentum and change it into linear, but we're proving that entirely wrong. Momentum versus velocity. Velocity builds momentum. But a lot of people say, well, we have to have momentum. And then they start ignoring the whole velocity thing. Velocity, as we know, is movement. It's movement in any direction, in any way, in any shape, any form. It can be vibration, it can be rotation, it can be sliding, spinning, hopping up and down. It doesn't matter what it is. It's movement will cause velocity, not to be confused, obviously, with speed of rotation. And simple formula aren't always accurate with this because they don't include the angular momentum and the time bases. Now, speaking of those time bases, time-based shifting is what is absolutely 100% required, as far as what I've seen anyway. Virtually all proposed centrifugal force-based closed-loop thrust machines have at least one fatal flaw, which is the lack of a consistently changing angular momentum time base. The force point, or the utilized mass, I like calling it a force point. Utilized mass have the velocity change involved in order for true closed loop propulsion to occur. So the force point would be something that causes a mass to shift position. The time-based shift can be a simple RPM change, or it can be a much more complex directional change, which is often confused with impact force. Impact force is sometimes important. Impact force is many times used as a complex directional change mechanism, but it is not the same thing. Impact force is simply equals angular momentum velocity change. And the time-based shift also equals velocity change. Angular momentum, compounded momentum, time changes, they all equal advanced angular momentum with a time shift, or TAAM, TAM. Time advanced angular momentum. It's a word we throw around in our shop quite frequently. We want to make sure that we don't ignore it, that we have the proper TAM as we're moving through the angular momentum changes. If we remove the time-based shift, and the centrifugal force alone cannot get it done. If centrifugal force was all we needed, if it was capable of generating true linear thrust, then we would also have perpetual motion, and it would be so much easier to achieve. Simple gravity or a free-floating pinion, it would always be heavier on one side. It would make these wonderful perpetual motion machines that we know don't happen this way. I'm not going to say they're impossible because I'm not sure anything is anymore. What we need is angular momentum with a dynamic mass redistribution. It's a requirement for TAM, and it's what we absolutely have to have in order to have linear propulsion. So the design evolution in our machines here, the Pi system, from the Thornton, we moved to the Pi 1.0. We made some considerable changes between Mr. Thornton's original device, although it looks much the same. Then from the Pi 1, we moved all the way to a Pi 4.9. And then from the 4.9, we're now building the Pi X. The Pi X now being called a Trammell engine. And Trammell is more or less a tongue-in-cheek name that I came up with for it, because the Trammell was considered a do-nothing machine. It was something with no real purpose. And we're taking a lot of components inside our machine that were considered as useless pieces of mechanism for something else. We're putting them to work in a whole new way. The Trammell engine, the Pi X, it's based on the work of Dr. Mike Marsden. He was the inventor of the Mach 1, and it uses we have two low quality videos of the Mach 1 that are still known to exist. I have a copy of both of them. A small group of people around the country, the US, have been working together to collate the design details. Some of this information is pretty close to 20 years old, and not much of it has been saved and recorded. There have been a lot of, well, there have been several attempts to replicate it. No success so far, but I am changing that now. We're working together. We're building a machine that really and truly does work. The Trammell engine has some limited success with a lot of failures. We're looking at about a 20-to-1 ratio of failures to successes. Talking about the Mach-1 1, yeah, if it'll, there we go. Dr. Marsden stated that it uses a series of spinning discs to create thrust. That's kind of like saying a jet turbine is a series of spinning blades to create thrust. If it was that simple, obviously, I think we would have had this replicated many years ago. To the right is a photo extracted from one of the videos showing Dr. Marsden with his Mach-1 1. And right around 2011, Dr. Marsden dropped out of public view and his website was removed. I have not personally spoken with him, but reputable sources say that he was forced into selling 100% of the rights and was issued what amounts to a gag order. So therefore, he will not speak about this to anyone or with anyone. I do have the video here. It was the Mach-1 advertisement that was put together by his son. It's only a few minutes. If the volume is a little loud, I'll just warn you ahead of time that it does seem a little loud. So I'm going to play that for you right now.
Mark Marsden of the U.S. Plastic Billiards Research and Development Facility in South Texas. What I'm going to show you will absolutely astound you. Through a series of spinning discs, this machine converts angular acceleration and angular deceleration into linear acceleration. This breakthrough technology can be called a new type of propulsion device, a mass displacement system, or even an anti-gravity machine. We That one weighs 32 pounds and it is tethered to this bathroom scale. When I turn the machine on, its weight will drop suddenly from 32 pounds to 0 pounds. This will cause the scale to bounce up and down before settling down to a more consistent reading. What you're about to observe is not a trick, it's not a dream, this is real. One was just now turning about 1,000 RPMs, and in earlier runs at higher RPMs, it literally
I didn't mean for it to stop that way. That was entirely my fault.
This will cause the scale to bounce up and down before settling down to a more consistent reading. What you're about to observe is not a trick, it's not a dream, this is real. One was just now turning about 1,000 RPMs, and in earlier runs at higher RPMs, it literally came. Remember, this is just the beginning. 1, 2, and beyond will power spaceships at a constant 1G acceleration. We'll go to the moon and back in an afternoon, or go to Mars in 3 days, not 3 years.
Okay, the earthport1.net website went down somewhere around 2012. And if you were to search for that on the Wayback Machine, you may or may not even find snippets or bits and pieces of it. It acknowledges that it did exist, but that information is pretty much lost to us forever. So what the Mach-1 1 and the Trammell engine do have in common with one another, both have a series of spinning discs. Both are motor driven from two sides. They both use angular acceleration and deceleration. They use linear components. They both have TAM, 4 times per revolution. And the strength of the thrust is based on RPM. The faster it turns, the more thrust there is. With the pi system, it always had to be kind of tuned to the harmonic resonance of the chassis it was hooked to, and thus we could come up with the most efficient speed to run it. This is truly a next level PI, or pulsed inertial engine. So on to part 3. I told you this wasn't going to be a terribly long presentation. First, we will take a quick look. Unfortunately, I have had to cover up some things, but if you compare the picture on the left with the picture on the right, during our last demonstration, the picture on the right, we had it covered up with cardboard, and you could see some physical levers that were moving up and down. We had some issues internally with the system kind of backfiring. Internal component would suddenly try to turn in the opposite direction. We would cause all kinds of absolute terrible damage. And some of that damage looked like that. So sometimes those changes that we've made had some less than desirable results. And so now, last for today's presentation, I do have a short 3-minute video where we compare the original PI system to Trammell-like designs. So here we go. And that pretty much summarizes our presentation for the afternoon. I want to thank everyone for allowing me to present here today and for the interest that's been built around the PI system and the Trammell Engine, the PI-X. Thank you all for accompanying me on this journey. For more information, you can go to my website, www.stclairtech.tech. My email information and everything is right there if anybody has questions, comments, concerns, or anything else that don't get covered in this presentation. I would be more than glad to cover those there. So with that, I guess we're basically about done. Let me Let me see if I can get this back from the screen share. Stop the share. There we
Okay.
go.
There we go. Yep. And I removed the spotlight too. So let me see. We are at the top of the hour. We could take a couple of questions. And actually, we're way ahead of schedule. I didn't realize that. Mark said that he doesn't have anything for TeslaTech until 6:30, but I think so. I don't know. You guys messed me up with your time zone stuff. Hey, wait, Brian, you're in Nova Scotia, aren't you?
No, I'm in New York.
Oh, okay. So you're 3 hours ahead. I was gonna say Nova Scotia is like 4 hours ahead. There's no way I'm dealing with that time zone. I'm like,
No, we're 7 o'clock here.
okay, yeah. Well, let me see. Oh, Michael has his hand up.
Hello.
Hello.
I was wondering if you considered suspending the machine from a helium balloon, something like that.
I have. I've considered that. There have actually been a lot of considerations. I've also talked to Mark Sokol about it. He said that there is someone that we can get a hold of who could put it in one of the, I don't remember what they call it. It's a 0G dive in a plane. Where they go up extremely high and they go into a dive which simulates zero gravity. So we've considered doing that as well. I kind of wanted to get a little further along with the Trammell design first. We're getting awfully close. I mean, we've had it produce upwards of 9 to 15 pounds of thrust, but it kind of put itself apart right about that point. So we're beefing up the internals. We're rebuilding. We're making it a little bit better, a little bit stronger. I know I didn't present it here, but there is a video that I've just uploaded to YouTube that shows a different version of what we call the Lola, which was a linear oscillating linear device. And that kind of shows how the internals of the system work without showing how the internals of the system work, if that makes any sense. Once we have it a little bit further along, I love the idea of a helium balloon. I think eBay or someone sells the large weather balloons, and I know we can just pick up some helium tanks and put it on a tether. That would be a lot of fun.
Thank you.
You're welcome.
Awesome. Okay, so let me see. Let me go to Bill Alec. Bill, there you are.
Yeah, hi, Brian.
Yes.
Yeah, have you heard of Mike Gamble?
Yes, I have. Yep.
Oh, okay.
I've been in touch with Mike. Yep, and he is using another form of that that linear acceleration coming from the angular momentum changes, and just like I spoke of in the presentation, the time-based shift. I know Mark Sokol could back me up on this a little bit more because he's also replicated some of Mike Gamble's work. That time-based shift is very important, where with his machine, it moves the spinning gyros at one speed in one direction and a different speed in another direction, extracting more force out of it one way than the other. So yeah, absolutely. I like Mike Gamble's work. He's done a really terrific job.
Mm-hmm. Did he ever tell you the story about Boeing? You know, he's a retired engineer from Boeing.
Yeah, he has.
Okay.
I know that some of that stuff is still classified, but I do know that a lot of what he has built his little tabletop unit on is based on things that have been floating around in our orbit for many years now.
Okay. Yeah, that's all that I have.
Well, thank you.
Awesome. Okay. Well, thank you, Bill. So again, let me go back to my thing here. It is Option Y on Mac or Alt Y on Windows. Let me go to Harold. Harold, sir.
Well, hey, thank you for your presentation. That's wonderful to see your machine working. One question for you. what role does the gyroscopic forces play in your machine and the Pi X? Are you using that or just purely centrifugal force?
The gyro forces are being used, but not to as big an extent as the centrifugal force. The centrifugal force is storing the power to make the machine work and move. Gyroscopic force is being used, but only in the form of precession. The actual gyroscopic force of the unit is negligible in its own operation. It will assist in stability once it's in the air, in space, or wherever it ends up going. But it's not really a big consideration in the amount of thrust that it's producing.
So you are canceling any gyroscopic forces that are being produced by having counter spinning rotor moments?
Yes, there are for every 4 revolutions of the disc, there are 4 time-based changes for different thrust settings, and there's a lot of parts behind that little smiley face that I'm just not quite ready to show yet.
That's fine. But the other question is that, have you done, close to the balloon test? Would be like a double pendulum test. Have you done any of that? And how many degrees does it deflect to one side?
Well, I did it before I moved it the last time, and I've made some considerable changes since then. Deflection, we were getting close to 3 inches of deflection on a 15-foot drop, but that was right when some bad stuff started to happen inside it. It started making horrible noises, and I had to stop that test before I was able to get a video of it. I was also pulling about 9 pounds of thrust at that time. So it was considerable. It was good for an early run, an early test. We were still using external levers to try to eliminate some backfiring problems within it, where, like I said, there were some spinning pieces in there that would attempt to suddenly change direction because the sudden time-based change was so dramatic that they would literally reverse direction. So yeah,
I noticed.
Yeah.
I noticed a lot of gear in there. Are you using some kind of lubricant to make sure that your spinning component do not wear out so fast?
I use the Lubriplate black spray grease a lot. That stuff is terrible. You get it on your hands and it gets on everything. You can't even wash it off. But on the other hand, it stays put, and anything that slides, and anything that spins, and it stays in place pretty well.
Oh, that's good. Well, thank you for showing that great presentation, and I hope you succeed on that one, because if you do, you're going to change a lot of minds, since inertial propulsion is considered to be very impossible. I mean, I know I did a lot of inertial propulsion experiment, and I wasn't that lucky. So I wish you the best.
I've seen a lot of your YouTube videos. They're very impressive. I really enjoy seeing your work.
That's what I did, because I failed with the initial propulsion. Patent office won't give me the patent. And so I'm moving to purely reactionless by electromagnetic forces. So, and I've been placing it, on YouTube to show, hey, there's something there. So, hey, thank you once again, and best of luck. I hope you succeed.
Thank you very much.
Interesting. There's all different paths. Harold, if you go to if you go away from the mechanical stuff, I used to get shocked a lot all the time. So, okay, let me go to Casper next, sir.
Yeah, hello. Thank you for the presentation. You mentioned a time-based shift or something like that. Can you explain what that is?
When any of the successfully working machines, just like the original Pi 1 right on up through the Pi 4.9, as things would rotate, they would suddenly have to speed up and slow down. That that is the time-based shift, the basic time-based shift that we have to have in order to be able to produce any kind of sustainable thrust. Unfortunately, with the pi, the early pies, the 1.0, the 2, and the 4 series, the rotation is very dependent. The rotation speed is very dependent on how much mass it's trying to move. So they literally are tuned for RPM per what they're being hooked to at the time. If it's just by itself, it can spin at 1 RPM. If it's hooked to something larger, it needs to spin at a slightly different RPM. That with the Trammel engine, with the Pi-X, that has produced very small thrust at very low RPMs, and it simply built from there. So that's what we're dealing with that. And those time-based shifts, they pretty much stay put. We don't have a timing change as the RPMs change.
Okay. Are the engines run by battery?
Yes, this one right now I've got that. I've got a 48-volt DC brushless motor on it to make it run. Yes.
And how big would that machine have to be in order to be used in a balloon or something? I mean, that's the application possibilities, right?
Oh, absolutely. This one is kind of built to be a little more bulletproof, so it's very, very heavy. I would want to rebuild it more out of aluminum than the steel that it's framed up with. Right now, we're sitting at just right around 200 pounds, the way it sits.
Okay.
Dr. Marsden, with his, he had his right around 36, 38 pounds. So I mean that's a lot more.
Very light.
Yeah.
And is it a plus to have it very lightweight, or are there cases where it's better to have a very high velocity, very high weight?
That's a great question. I wish I had a true answer for it. With the early pies, you needed mass. If the less mass there was, the worse they actually worked. It didn't matter if it had friction or no friction. It would work just fine with the smallest amount of friction that you could possibly generate without being in space. But without enough mass, it just did not function correctly. I'm going to be very interested to see how the new system works with heavier mass and lighter mass.
I mean, would this be able to withstand, let's say, medium wind strength? Or I'm not a physicist, so I use the wrong words, but get my question. You know, how much could it resist a wind or storm or something?
Well, as far as its physical strength to withstand, outside forces, it's built pretty strong. I don't think I'd want to drop it on the floor from a tabletop, but I don't think that it would really hurt it all that much either. As far as how much thrust it produces, that's what I meant. Yeah, that's yet to be seen. I'm really shooting for somewhere in the 50 to 100 pound of thrust range, but I might be shooting a little high with that one. I don't know.
And how much is that considered to a jet engine or something? It's way less, right?
Well, it's a lot less than a jet engine, but it's also how much energy is being put into that jet engine and jet engine fuel to get that much out of it.
Of course.
So if we had a series of these set up and running, I'm going to, without doing the math exactly, I'm going to say that they would probably use about 1/10 of the amount of energy input, or possibly less, than the jet would have for the same amount of thrust output.
So, if it's okay with one more question, is it mainly made for space traveling, or is it also to be used, I don't know, to travel from Denmark to England or whatever?
I want this to be able to be used for everything. Cars, trucks, boats, airplanes, spaceships, satellites, submarines.
And it's a way much greener way to transport ABC.
Oh, absolutely.
Yeah.
Absolutely. It'll run on any kind of a spinning input. So it doesn't matter if it's running on an electrical motor or if it's running on a gas engine, diesel engine,
Wow.
steam engine, or anything else.
Best of luck to you, man. Thank you.
Thank you.
Sorry. Awesome. Yeah, so I mean that was everybody I think who had questions for now, and we've got about 40 minutes. So Bryan, I don't know if you want to present some more, or if we could just go to open discussion. Before we do that though, you know what? Let me put this thing on gallery view. I owe you an applause, sir. Everyone, please put your hands together. And
Yeah,
give a
man.
Thank you to Bryan Sinclair. Bryan, thank you for giving us updates on this. That's
No problem. I enjoy giving updates on it. Every time I talk about it, I think of something new. I'm like, I need to write that down before I forget.